Hi, welcome back to Mechanics and Control of Robotic Manipulator. So last class what we have seen basically like a Danavitt-Artenberg representation, especially we arrived the term called arm matrix. Even the arm matrix can be obtained two way, one is standard, the other one is non-standard. So we are going to use a non-standard. The non-standard is nothing but the mix of I minus 1 and I. So where the link parameter would be in the I minus 1 axis, whereas the joint parameter would be in I axis. So now in this particular lecture we are going to see, as I already mentioned in the last lecture, we are going to see something like a real manipulator. But although I said real manipulator, we will not be seeing real manipulator in the picture. So we will be taking real manipulator configuration and trying to derive the you call Danavitt-Artenberg parameters for given configurations. So this is what our intention here. So if that is the case, what we are going to cover, we are going to see so how to fix the frame, because there are number of frames we are going to fix. So there is supposed to be some procedure or norm which we are going to follow. In addition to that, we are going to see there are 5 such examples which are actually like coming from the what you call in real time. So these are actually like existing manipulators which we are seeing the first 3 axes for our own benefit. So even then actually there is an additional benefit also we would be having, that probably you would be coming to know when we attempt probably 2 lectures later. Okay. So that is the whole idea. Let us go to the what you call frame arrangement. Why we are thinking about frame arrangement? For example, you have several body. Okay. So how you can actually like fix your joint axis, and what way we can fix the joint axis? If you fix the joint axis, where you can fix your frame and where you can fix the x axis, all those things you need to follow. So for that we are going to follow certain small set of procedures. The first procedure what we are going to follow is, so you all know like joint axis always assigned to the z axis or z direction. So which is actually like corresponding to the concerned frame. For example, if I say so the frame 1, so the joint axis would be z1. Okay. So like that we are going to write. So if you do this, so how to fix this 1? So in the sense the frame location, in the sense the fixing the frame location is always a concern. For example, you have actually like 2 parallel axes, where to fix your 1 and where to fix 2. So there are several options, right? So for that we need to provide some kind of additional set of rules. So that is what we are going to call, if zi and zi plus 1 are intersecting at some point, so then that intersection is the frame location of I. Okay. So for example, this is what zi, okay, and there is actually like zi plus 1 which is going. Okay. So you have to actually like see where these two intersect. This is what the 1. Okay. So now additionally one more actually like going what you call the zi plus 2. So where these two intersect, this is the point I plus 1, like that we can keep going. So this is what this rule says. So if these two are not intersecting, neither intersecting non-parallel, or if it is actually like simply parallel, how we can fix it? So for that we need to actually like go some other cases. So if it is neither intersecting non-parallel, then we have to do some kind of virtual frames. Okay. However, if it is actually like parallel, then the you can say frame can be fixed at a convenient location, at the convenient point on the zi axis. Now you can see these two are actually like your zi and zi plus 1. So now you can actually like fix it anywhere on a convenient basis. Okay. So now in that case you can see that this is the common normal which you are going to draw. So then your xi can be fixed accordingly. So this is what the whole idea, right? So now what we have seen actually like what is zi or what is z axis arrangement. Then based on the z axis or axes, so we can actually like find the fixing of the frame. So what else we need to know? So we all know like this would be having 2 axis system. So obviously then we have to see how to fix x. So xi fixing is actually like always actually like easy, because it is actually like based on the nature of zi and zi plus 1. If it is actually like parallel, or you can say neither parallel non-intersecting, you can always draw the common normal between these two, and then you can actually like fix along that as your axis. Okay. So then that too like in the progressing side, then that would be your xi. Okay. This I say ith axis and this is I plus 1 axis, you can take it. If if these two are actually like intersecting and actually like it is perpendicular, for example like this. So this is Z1, okay, and this is actually like Z2. So then how you can actually like draw common normal? So then we can actually like see that the common normal may be like this, okay. But instead of doing that, what we can actually like do it, so we can actually like draw the plane, okay. This is the Z1 and this is parallel to Z2. So this plane is actually like going to consider as your axis plane, and you can actually like see normal to this plane, so your xi axis. So whether it is pointing inward or actually like outward, that is choice of yours. So provided if there is a length, then that length always in the progressing side, so that the link length always positive or 0. That is the way we can actually like consider, okay. So now you get to know. So when we see the example, you would be getting much more clear, okay. That is what we said. So the xi axis perpendicular to the plane containing zi and zi plus 1 axis, okay. So what else we need to know? So we supposed to know the link length is a physical parameter that cannot be negative, okay. So in the sense, this is a geometrical parameter that cannot be negative. How the mass cannot be negative, the same way the link length cannot be negative. So in that sense, xi always properly assigned in such a way that this link length is considered as a positive one. For example, now, so this is zi, okay, and you have actually like zi plus 1 here. So what is the choice of xi? So obviously the plane containing, the perpendicular to the plane containing. So in that sense, what would be the plane? So this is the plane containing. So what would be the direction of xi? So either this side you can go or this side we can go. So now what one can actually like see, so the link length supposed to be positive, so you can fix xi this way, okay. This is what this particular rule all about saying, okay. So now we will move to the real example, okay. So before that, you just recall what we derived as a ARM matrix based on what you call non-standard form. So why we call non-standard? You can see these are actually like in I plus or I minus 1 frame, and the other what you can say, these are actually like in what you call in I representation. So that's why it is we call non-standard. There is no other specific reason to call non-standard, but this give a more intuitiveness. So that's why we are following this. So now we just recall this matrix, because we are going to substitute this Danavid-Artenberg parameter of individual frame, and then we are going to get something else out of that, okay. So for that, what we are trying to do, we are trying to find out actually like some example we will take and we will substitute and get it how it is going on. So for that, one classical example, what we call an articulated manipulator. What it means, articulation or articulated, it is going to articulate, and especially it is having all rotary joints. So how the rotary joints assigned? So first rotary joint is actually like vertical, that is second rotary joint is perpendicular to that, okay. The third rotary joint is parallel to that, okay. So in that sense, what we can actually like get, so these two axes make a planar motion. That planar motion you can sweat with respect to this axis, you will get a 3-dimensional case. So that is what the whole idea. I hope now you are actually like getting somewhat a clear idea. So now we will see how to fix the frame. So for that, I am actually like using it here. So what one can see, so this would be actually like your z1 axis, because the first rule says that the joint axis supposed to be z axis. So here this is the first joint, so that why I fixed as positive direction also they have given. So that is what z1 axis, and this is z2 axis, and this is actually like z3 axis. So what is the next rule of thumb? So you have to actually like fix the what you call frame, right? So what you can actually like see, it start from 1 to 3. So you have to obviously start from 0 and end with 3 plus 1, right? So then you can see like you have to fix the frame point. The first fixing frame point you can choose, but right now we assume that this is the base. So I can start from here as 0th frame, okay. So now the second frame location, it is actually like EC. So what EC? So you have to see that if take Z2 and Z1, whether it is intersecting or not. In this case it is intersecting, so the intersection point is your frame 1. So now Z2 and Z3 are actually like parallel. So you can take a convenient point. So I am taking the same point as 2, which is actually like giving much more simplicity for me. So further what you can actually like see, so you call the forearm, which is actually like the final tool. So that tool Z axis you can choose. Okay. So right now I am assuming that this is parallel to this, then you can see conveniently you can take anywhere on the Z3. I am taking where these two intersect. This is the point I call 3. This intersection is just the link intersection. Okay. So now this is the point 4, which is that is the end, right. So now the same thing I am drawing it here, okay, just for your benefit. So I am just drawing it here. So what we did, this is 0 and this is 1 and 2 and this is 3 and this is 4. So what else we know, I am actually like drawing this. So this is actually like Z0 and this is Z1, okay, and you know this is Z2 and this is Z3 as per the configuration, and the final one is my choice and the beginning also my choice. The beginning choice I took it as this because we always take this is what X and this is what Z, right, because the Y would be going inside, right. So that is what the right hand rule all says. So because of that consideration I have taken. So now what else we need to see? So we need to fix the X axis. For fixing X axis, what we can see, the Xi you have to see based on Zi and Zi plus 1 coordination, right. So if I take that way, so what is the X0 configuration? That need to be C, Z1 and Z0. So what is the Z1 and Z0 nature? These two are parallel, that two in the same line. So in the sense you can take X0 anywhere, either actually like orthogonal to the Z0. In the sense you can see like in this plane anywhere you can take. So I am taking it actually like a very simple idea. So what that? So I am actually like going to take what we used to do as a conventional. So X0. Now coming to X1, what we need to see? So X1 would be the plane containing Z1 and Z2 perpendicular to that, right. That is what the X1 direction or the axis. So and the direction what you can actually like feel it. So that is the progressing direction. So that I can take this, and Z2 and Z3 are parallel. So I can actually take X2 in that way. So similar way I can take this X3 and X4. So what it is giving? It is giving X4 is parallel to X0 and you can see Z4 is parallel to Y0, okay, and Y4. So what would be the Y4 direction? So you can take a right hand rule again. So this is thumb and this is actually like forefinger will go in, then only you can get it, right. So that is what the case. So then you can see Y4 parallel to, you can say Z0 but opposite direction, right. So that is what you can actually like see it. So now we will actually like come back. So we can actually like see what exactly we have done, that I am actually like trying to show with a DH parameter. So what are the link length and what are the geometrical parameter you can expect here? So you can see that there is one length here, right. So that length somewhere, and there is another length you can feel, and there is another length, right. You can physically see this to this there is a physical length, this to this there is a physical length, and this to this also there is a physical length. Now how we are naming it that length, that is actually coming you can say in a few seconds later. So now we will actually try to draw what you call you can say like simple DH parameter. So we will actually like try to see that. So I am just drawing it that. So I am actually like trying to give that in a tabular form, okay. So how many will come? So there are actually like, so 4, because 1, 2, 3, 4, and this is I call I, this is alpha I minus 1, then A I minus 1, and this is theta I, and this is d I. So what we are actually trying to see, what is actually like alpha I minus 1. What is alpha I minus 1? This is angle between Z I minus 1 to, you can say I will write to Z I with respect to X I minus 1. This is what you have to see. So if you see here, So is there any angle between z1 and z0 with respect to x0? No, right? So is there any distance along x0? No, right? But is there any angle with respect to x0 or with respect to z1 where the angle between x0 and x1 is there? Theoretically no, okay. But what happened, this is one of the active joint which can have theta 1 in the sense 0 plus theta 1, okay. So what else you know? So the distance between 0th frame to first frame or one frame along z1, what is the distance? That is what you call joint distance, that is d1, right. So now you got some, you can say, idea. So how to find the DH parameter, right? Let us go to the next one. So what is next one? So alpha 1 we need to find out. So in the sense alpha 2 minus 1. So what that? So it is actually like angle between z1 and z2. So theoretically it is 90 degree, but what direction? So you can see like x2, you can actually like see x2 fix it here, okay. So when you fix it x2 here, what is the direction? It comes this way, right? So in the sense what you need to do, so you need to rotate this 270 degree to make it parallel to z2. So the z1 supposed to rotate about x1, rotate 270 degree to make it parallel to z2. Otherwise what you can write? You can write minus 90 degree. So I always prefer to go in a conventional way. So you can write that is, you can say 3 pi by 2 in the sense 270 degree, and there is no distance along x1, so 0, and this is actually like again active joint, right. So in the sense that is 0 plus theta 2, and there is no distance along z2, so that is 0. Now coming to third frame. So the frame 2 and 3, how much difference it is? So there is actually like no angle, because x2 along x2 or about x2 there is nothing an angle, so that is 0 in the sense z2 and z3 are parallel. So what is A? So A would be realized along x. So in this case x2 is actually like you can see there is a distance along x2 where it is traveling from 1 to 3. So this is what we call in this case A3 minus 1. So in the sense this is A2 and this is D1. So this is I call A3. So now what you have? So this is again an active joint. So in the sense 0 plus theta 3, and there is no distance along z3, right. So now coming back again, so z3 and z4 are parallel, so there is no angle. Along x3 there is a distance, that is a3, right. And what else you know? So there is no active, so it is 0 degree, and there is no distance, it is 0, right. So you got this. So now we will actually like go the same thing in a pictorial way what I did it already. You can see, right. So this is what 0, and this is 1 and 2, and this is 3 and 4, and we have actually like fixed z1, z2, z3 which are given, and the z0 and z4 are choice. So I keep it as per my own, and x0 to x4 we have to fix it. So we have fixed it based on the rule which we have used. So now based on this what we have actually like found. So we have actually like found what you call the DH parameter. So the same DH parameter what we obtained, we can actually like cross check here. So you can actually like cross check here. So this is the you can say frame arrangement which we obtained as per our understanding. So based on this what we got? So we got the DH parameter. Only thing I did not put zeros anywhere, because 0 plus theta 1 would give theta 1 only, right. But you have to keep it in your mind. So theta 1 is the active joint. So that is not realizable here, but that is actually like power joint. So that's why we are putting theta 1 as a variable. So in this particular case all are actually like this, all 3 thetas are variable, okay. So now we will see this, we can put it in ARM matrix, what would be the transformation matrix. You can actually like recall the second slide and then you can substitute this. So you will get T01 as this, right. So then what else you will get? T12 you will get, and in the sense transformation matrix of 2 with respect to 1, transformation matrix of 1 with respect to 0, like that you will actually like keep getting it, right. So up to what? So 4. But what we are really interested, we are really interested to find the transformation matrix of 4 with respect to 0. In the sense what I can write transformation matrix of end with respect to the base. So this is what we interested. What we know, we can actually like post multiply this in the sense t is 0 1, t 1 2, t 2 3, t 3 4. You multiply, that would be equal to this, right? So that is what we are actually like going to do. Okay. So this is what we are actually going to do. Now if you substitute and get it, finally this matrix will come. So now the task is not ended here. Why? Once you obtain this, you have to actually like cross check whether whatever you obtained your DH parameter are, you can say, correct or not. So how you can actually like cross check? There is a procedure which we used to follow as a student or as a researcher. So what is the procedure? So you can actually like recall here the frame arrangement. So what we have arranged? We have arranged actually like everything in this form. So if you assume that this is the home position, so what would be the theta 1? So we have obtained, right, theta 1 is 0 degree and theta 2 is actually like 0 degree and theta 3 is 0 degree. If you take this, all are actually like zeros. So what would be the x displacement, or you can say the x position of 4 with respect to 0, what would be that? That would be, you can see x4 is parallel to this in the sense a2 plus a3, right. What would be the y displacement, or you can say y position of 4 with respect to 0 frame? So that would be 0, right, there is no displacement. What would be the z equivalent? You can see that this and this point is actually like along z0, what is the distance? That is d1, right. So whether we are getting this or not. So similarly what one can actually like see, so based on this the rotational information you can see. So if you project x4 on 0 frame, what it would come? X4 and x0 parallel, so it will come 1 0 0. So y4 is here. So if you project y4, what would be that? That would be 0 0 minus 1, right. If you project z4 to 0 frame, so that would be 0 1 0, right. So this is the rotational matrix and this is the position vector, right, on the home position. We can cross check whether you are getting this once you obtain the matrix what you found here, right. So how we can substitute? So you substitute, so theta 1 equal to 0, theta 2 equal to 0 and theta 3 equal to 0. So what become? This become 1, this become 1, 1 multiply 1 is 1 and this becomes 0 and this become 1 and this becomes 0. In the sense you can see this is giving 1 0 0, right, this is matching. So now you can actually check here, this is 1 and 0, this is 0 and 0. So in the sense 0 0 and this is 1 but minus is there, so minus 1, this is also matching. So here you can see 0 and this is 1 because theta 1 0, right. So cos 0 is 1 and this is 0, right. So coming back here, this become 1, this also become 1, this also become 1. So what left? So a2 plus a3 left, but here this itself is 0. So no need to see because this is 1, this is 1. So 0 multiply with anything is 0 and finally you can see this is actually going to be 0, this is also 0. What left? d1, right. So in the sense what you obtain? So you obtained the one which you have seen as a home position that you have cross checked, right. So that is what I said, this is the last task. Once you obtain DH parameter, you derive this, you can say the final transformation matrix, in the sense transformation matrix of 4 with respect to 0, you calculate and substitute your home position and cross verify. Okay. The similar kind of example we will see in the upcoming lectures. So until then, see you, bye. But you please keep it in your mind, the frame arrangement is one of the critical point. You keep remember the thumb rule because once it comes into practice, it is easy. Okay. So thank you, see you then, bye.